In this video, I'm going to demonstrate 3 distinct ways to deploy a SQL Server Database in Azure. Via the Azure portal, by using Azure Command Line Interface or CLI commands, and by using Powershell. I'll be performing the Azure CLI and Powershell commands using Microsoft's Cloud Shell, which incorporates both Azure CLI and Powershell in a common command line interface that's accessible online. So I'm going to start off by showing you how to create the database in Azure Portal. So I have Azure Portal open, and the first thing I'm going to do is go to my resource groups, and I'm going to create a resource group. So I'm going to click Add, and resource groups are really simple. I'm just going to call it Azure. And of course, that name's already taken. Somebody's already used that. So I'm just going to add a common number I use at the end to make it unique. I'll hit Review and Create, and hit Create. So I'll click on the resource group Azure 26, and I'll click Add on the overview. And now what I do is I type in Sql Database. There's an option for Sql Database, so I'll click on that, and I'll click on Create. Now what this does is it creates a SQL Server and an associated SQL Database all in one. So I just have to fill in some basics here. My resource group is already filled in because I went from there. Under Database Details, I have to give it a unique server name. So what I'll do is I'll click Create New under Server and give it the server details. So under New Server, I have to give it a unique server name. So I have to give it an admin login. So this is my administrator login. So I'm going to call it bbrooks26. And I have to give it a unique password, and I have a common password I use for this demonstration. Confirm the password. And I can click OK. Now I need to give it a database name. I'm going to call it MyDB. Hit Review and Create, and hit Create. So that's going to create both my server and my database. Now this is going to take a few minutes, so I'm just going to pause and come back when it's done. Okay, so that's finished, and now I can go to my deployment. Go back to Home and hit Resource Groups. And here I can see, if I go to my resource group Azure 26, that I now have 2 resources. Azure Server 26, which I gave it the name for the server, and the database MyDB. So it creates both of those things. Now, if I go to MyDB and I click on Query Editor on the left, so now I can log in, and if I type in my password, it already automatically fills in my administrator login, which is bbrooks26. Now there is an error here because you have to set up the firewall. So I'm told that my IP address is not allowed. So what I can do is go to Overview, and at the top of Overview there's a Set Server Firewall. So if I click on that, then under the firewall settings there's a client IP address. So under rule name I give it a name, and I'll just call this the client IP, and I'll give it start and end of that same IP address. Now I can give it any IP address range I want. Now what IP addresses you open in this firewall will depend on how you're going to use it. But for this demonstration, just opening that one client IP should do the trick. So if I go back to MyDB and I go back to Query Editor, and now I'll enter my password again, okay, and click OK. So now I can run queries. So that's fully set up. Now the next thing we're going to do is we're going to use Azure Command Line Interface. This is in Microsoft Docs, and it's called Quick Start, Create an Azure SQL Database Single Database. So you could go to this public website and do this for yourself. So under Create a Single Database, I'm going to go to Azure CLI, and I'll step you through the steps to create the same thing. And what I'm going to do is I'm going to use what's called the Azure Cloud Shell. And the easiest way for me to do that is to click Try It here on this Azure CLI section. And it actually opens up the Azure Cloud Shell. So that's connecting to the terminal. There we go. So it's logged in as me because I'm already logged in. If you're not logged in with Azure credentials right now, then what it'll do when you try is it will ask you to log in. So let me show you the steps that we need to take. It's going to be the same set of steps. And I will step you through the commands here. So I'm going to paste the first command. This is to create the resource group. It's AZ group create, --name, and this is the name of my Azure group now. I named the other one Azure 26. This one I'm going to call Azure CLI for Azure Command Line Interface. And --location, you have to tell it what region to install it in, and I'm just going to go with East US because that's the default. So I hit enter. Now that's successful, and it gives me all the details of what it just created. So that created the resource group using Azure CLI. Now the next step is to create the SQL Server. Now this doesn't do it all in one step like the Azure portal did. We actually have to do the same steps, and in fact the Azure portal is almost certainly doing the same steps in the background. It goes AZ SQL Server create, and the name is CLI Server 2626. That's just a unique name. Resource group is Azure CLI. That's the resource group we just created. Location is just a default, East US. Admin user is my bbrooks26, and I've included my admin password. So if I hit enter, it says it's running, so it's now creating that SQL Server. Okay, so that's completed, and you can see that it gives me all of the details of that SQL Server that it's just created. So the next step is to create that firewall rule. Remember the firewall rule I had to do in order to log in to my SQL Server. So I'm going to add that. So what we have here is AZ SQL Server firewall-rule create. I give it the resource group, the name of the SQL Server. I give it the name of the firewall rule, which I just call IP range, could be anything. I give it the start IP and the end IP. This time I just go from 0000 to 255, 255, 255, 255, so it will allow any IP address. Of course, if this were a production instance, you'd want that to be more specific. So it's already created that fire rule. That was really quick. And now the final thing is to create the actual Sql database that's part of the SQL Server. So I click paste, AZ SQL DB create, and I give it the resource group, the server name, and the name of the new database. So that's my DB. And the rest of it is specifics about the database. So it's a general purpose edition database. Its compute model is serverless. Now those are specifics that you can look up as to what you can set on that. I'm going to click enter. Now again, like the server, this is going to take a few seconds. So I'm just going to pause until it comes back. Okay, so that has created the database and give me a bunch of information about it. So what I'm going to do now is I'm going to go back to the portal and let's just take a look at what was created. So I'm going to go back to my portal home and I'm going to refresh. I'm going to go to resource groups. And now I have a new resource group called Azure CLI, so I created it. If I open that up, I see my SQL Server instance and my Sql Database instance. If I click on Sql Database and I click on Create Editor, now I will enter my password and click OK. And now I'm in and I can query my database. So I did the exact same thing that the Azure Portal Wizard did, only I did it using Azure CLI. Now the next step we're going to do is we're going to do the same thing using PowerShell. So if I go back to my Quick Start web page and I click on PowerShell under Create a Single Database, I'm now going to click one of the Try It buttons under Azure PowerShell, and I'm going to use the Cloud Shell to do PowerShell. So let me show you the commands for doing the exact same thing. First thing we do is create our resource group. So the command for that is new-az resource group -name, and I'm going to call the resource group PowerShell, location East US, just like before. Click enter, and it's created that, and it shows us the properties. Next, I'm going to create the actual SQL Server. Now, I did this in different steps here, or different lines, and on the lines, there's a single quote that you can use in order to specify that you're going to a different line. So let me step you through this command. It's new-az SQL Server, resource group name, we've already specified as PowerShell. Server name is going to be called PowerShell Server 26. That's just a unique name I came up with. East US is the location, just like always. SQL Administrator Credentials. This big line just prepares my credentials. So the first thing it prepares is the argument list, which is my name and my password. So the administrator name is bbrooks26, and the password is my standard password. The rest of it is just boilerplate. So if I click enter, that's going to take a little while. So I'll just pause. Okay, that just came back and it gives me the details. So it's created my SQL Server. The next step is to create the firewall rule. So to do that, I use new-az SQL Server Firewall Rule. Resource group name PowerShell. Server name is PowerShell Server 26. I give it a firewall rule name, which I just call it again IP range, and I give it a start and end IP address. And that's created real quick. And finally, I create the SQL database. So this is new-az SQL Database. Resource group name PowerShell, server name PowerShell Server 26, and I give it a database name of MyDB. And it has the same sort of settings. There's a few extra settings in here: vCore, minimum capacity, compute generation. So it's settings just like we did with the Azure CLI. And there are other settings. We're just using some of the more basic ones. Click enter. And again, this will take a few minutes, so I'll just pause. And it's come back and it's completed creating the database, and it gives me all the information. So just like before, let's take a look at what happened in Azure Portal. So I'll go to Home in Azure Portal, and I will go to my resource groups. And now there's a resource group called PowerShell. And if I open that up, again, I see my two resources that I told it to create: SQL Server, Sql Database. If I go to the Sql Database and I click Query Editor, just like before, I'll fill in my password. Click OK. And now I can see the editor. So in conclusion, what I've shown you here is 3 ways to create the same SQL Server and SQL Database setup. Now the nice thing about being able to script this is that you can have automated scripts doing it, so you can automate this process. Many technologies that were once strictly on-premises have been moved to the cloud, and one of those is Azure SQL Database. In this video, we're going to look at the workings of Azure SQL Database. Azure SQL Database is a platform as a service, or PaaS offering. This means that your database instance is managed 100% by Microsoft. Unlike an on-prem database, which would need to be managed by organizations' own operations employees, with Azure SQL Database, Microsoft takes care of maintenance operations, such as backups, patching, monitoring, and upgrading. So Azure SQL Database is always running the latest version of the Sql Server Database engine. Azure also offers 99.99% availability. Microsoft actually patches Azure SQL Database before it patches the on-prem version of SQL Server. So you get latest capabilities, such as high-performance in-memory technologies, which make your database more performant, and intelligent query processing, which makes workloads more efficient. There are 2 main deployment models available. You can go with a single database if you need dedicated resources. For example, you might have an application that needs low latency. With dedicated database resources, you can more easily guarantee performance. You can also choose an elastic pool of databases. In this case, multiple databases share a pool of resources. Now this is great if your database usage ebbs and flows. When one database instance isn't using resources, it's free for other instances to use. The downside is that resources are shared, so one instance could starve other instances of resources. Use cases should be considered here. Single databases can be moved in and out of an elastic pool as needed. There are also different purchasing order options. The Database Transaction Unit, or DTU-based purchasing model, gives you resource availability in service tiers, from light to heavy, depending on your needs. You're charged for the tier you choose. This would be good if you need dedicated resources and you can predict your usage fairly well. There's also Virtual Core or vCore based, in which you choose and are charged for the use of a number of vCores. This is another good one for fine-tuning dedicated resources. This option also allows something called the Azure Hybrid benefit for SQL Server, which allows you to use on-premises SQL Server instances with your Cloud vCore resources. If you prefer to use on-prem databases, this can represent significant cost savings. And there's a serverless compute tier. In this tier, resources are shared, but the resources you use will elastically grow and shrink on usage, so you'll only pay per second on what you use. This can be great if you have unpredictable throughput. If you go the service tier route, here are the 3 tiers offered. The general purpose tier is for standard workloads. If your usage is fairly light to average and you're budget conscious, this tier will probably best suit your needs. The next tier is a business critical tier. You'll want this tier if you're doing online transaction processing, such as managing the accounts of an online store. It also manages replicas of your database for recovery in the case of failure. And finally, there's the hyperscale tier, which is for larger transactional databases that need to autoscale both their storage space and compute needs on a regular basis. Elastic pools are a tremendous benefit of cloud computing. For some needs, you may not require elastic pools, which is why you can run Azure SQL Database as a single database with dedicated resources. This is good if your usage is predictable, but if your database usage is not predictable for a single database, but is more predictable over a group of database instances, then elastic pools may be the answer. You can blend single databases and elastic pools in your solution if you have a mix of database requirements. Elastic pools solve the problem of varying resource requirements for databases by allowing the databases in the pool to draw from a common pool of resources. You can set a cap on resource usage of the pool as a whole, and also control minimum and maximum resource usage per database. So with the proper configuration, you can consume only the resources that are needed when you need them, and this keeps your costs predictable. The SQL Server Database engine has built-in performance monitoring and insights. Additionally, Azure offers other monitoring abilities to determine database issues across many database instances. These tools can alert you of a range of issues and suggest ways to maximize performance. The Azure SQL Database can send this information directly to Azure Event Hubs for streaming to downstream services, Azure Monitor Logs for logging and monitoring, and Azure Storage to be analyzed later. Azure SQL Database also offers many capabilities for guaranteeing high availability, including automatic backups to ensure that even in the event of a disaster, your data is not lost, geo-replication, replicating your databases in different geographical locations to manage high read volumes from different areas of the world. Auto failover groups allow you to manage load balancing schemes and other routing and failover strategies. Point-in-time restores, which allow you to roll the database back. And zone redundant databases. For business-critical databases or elastic pools, it offers high availability and automatic recovery. Monitoring and tuning databases, especially at scale, can be a daunting task. So Microsoft offers tools that do a lot of this for you. Intelligent Insights monitors your database at scale, learning your database usage patterns and informing you of issues, root causes, and improvement opportunities. If you still can't keep up to all the work of tuning the database, you can take advantage of automatic tuning, in which the SQL database automatically does the tuning request for you. Automatic tuning will watch your database after each auto-tuning and will roll the tuning back if performance is not improved. This automatic tuning includes automatic plan correction that fixes plans, automatically managing your indexes to make them efficient, and adaptive query processing, which adapts how your queries are executed under the hood for maximum performance. One concern I've personally heard from customers in the industrial sector was whether their data on the cloud is as secure as the data in private data centers. Microsoft has gone to great lengths to ensure that data stored in Azure SQL databases are secure. In this video, let's look at some details of Microsoft security for Azure SQL Database deployments. The first thing to note is that all the security features we're going to look at are in addition to the standard security features of the Azure platform itself, which is designed with high security in mind. Azure SQL databases are limited, for security reasons, on what data protocols they support. They support only the widely accepted Tabular Data Stream or TDS protocol. This limits the communication to the 1433 TCP port. Azure SQL databases also preside behind a firewall that, by default, blocks all IP addresses. Databases need to be configured to accept communications from source IP addresses that are trusted. The SQL Database Gateway enforces validated, encrypted connections, and it's also protected by the Denial of Service or DOS guard. The DOS guard temporarily blocks any IP addresses that exhibit denial of service attack behavior. This reduces denial of service attacks by tracking failed logins and avoiding floods of unsuccessful login attempts. There are also security features built right into the internal architecture of Azure SQL databases. Hypervisor, which manages the virtual machines, limits traffic between root operating systems, which control the underlying database infrastructure, and guest virtual machines, which handle public customer requests. Not only is the root operating system isolated from the guest virtual machines, preventing direct access to the underlying database, but the guest virtual machines are isolated from one another, preventing customers from affecting each other. The virtual machines also perform packet filtering on incoming data to avoid unauthorized traffic. And finally, there are different levels of isolation within the virtual network or VLAN to restrict unwanted intrusion. So far, we've discussed the technical aspects that help make Azure SQL Database secure and guarantee security of your data when it's stored in the database. These approaches generally protect the database from inappropriate external activity. But databases can also suffer vulnerability internally if they're not properly managed. The Microsoft staff that manage the configuration of your Azure SQL databases have strict processes to ensure that your databases and their data are not adversely affected by changes, such as upgrades and patches. They have a central tracking system for changes to production. Before changes are made in the production environment, they're first thoroughly tested in separate test and staging environments to ensure that the changes are safe. There's a review process that ensures security and privacy checks are done before the production environment is changed. Changes need to be signed off by the appropriate people before they're deployed. And once deployed, changes are monitored, and if there are any failures, the changes are promptly rolled back. Microsoft uses an entire suite of tools for configuration management, including Azure Security Monitoring, which checks for standard security vulnerabilities, Git for managing changes in repositories, Master Data Services or MDS for viewing and managing the data in all environments, Runners for running suites of tests for quality assurance, the use of the Fabric controller to securely manage services in Azure, Source Depot, Microsoft's solution for software versioning, WinFabric for service management, and Team Foundation Server or TFS for managing teamwork. In short, Microsoft takes their internal processes seriously and uses a host of powerful tools to ensure changes are managed in the safest way possible. So along with the security features we've looked at so far, and Microsoft's secure handling of your databases behind the scenes, Azure SQL Database also comes with Azure Defender for SQL, which offers some advanced SQL security capabilities that look at the security of your database as configured and also your usage patterns. This includes vulnerability assessment, which searches for potential vulnerabilities based on how your database environment is set up. It gives you steps that you can take action on to increase your security footprint. There's also threat detection, which looks for unusual database activity. This performs continuous monitoring and can send real-time alerts on vulnerabilities, such as SQL injection attacks or suspicious access attempts. It can also give actionable suggestions on how you can mitigate the problems. As I've mentioned, if you're managing customer data in Azure SQL databases in the cloud, your customers may require assurance that their data is secure. In some cases, there may be regulatory compliances that you have to meet. To help with this, Azure SQL databases have a suite of auditing features. First, user authentication and authorization are managed and audited via integration with Azure Active Directory, which is Microsoft's solution for secure cloud identity management. With Azure SQL Database, data is always in an encrypted state, at rest, in motion, and also in use. Data discovery and classification is a SQL Server tool that will help identify, classify, and label the most sensitive data in your databases. It will audit access to that data, not just in the database, but outside it as well. And the Azure Active Directory integration offers further security by offering multi-factor authentication, a more secure authentication than the well-known user password. Used by many organizations requiring a high level of user security, such as bank portals, multi-factor authentication requires the pairing of another factor or method of authentication along with username and password to prove a user's identity. Some common extra factors are emails or text messages sent to the user with a special passcode that has to be entered. With multi-factor authentication, you can be more assured that your databases are not being accessed by unauthorized individuals. In this video, I'm going to demonstrate 3 ways that you can set up an administrator user for authentication in SQL Server in Azure. Now, the first one I'm going to show you is already set up, but I'm going to just step you through how it works. So in the Azure portal, I have a resource group called Azure 26. And if I open that up, I have my SQL database called MyDB, and it's part of a SQL Server instance called Azure Server 26. Now, when I set this up, I already created an administrator user. Whenever you set up a SQL Server in Azure, it always asks you for an admin username and an admin password, and that's automatically set up for you. So if I go to MyDB database, and I go to Query Editor on the left, I'm going to be asked to log in. And I can use those credentials to log into the SQL Server authentication. Now my admin username I set up was bbrooks26, and I'm going to put in the password that I gave when I first set this up, and I'll click OK. And you get access to set up a query, and I can show you that I have admin access by create table. So I'll just call it admin test. I'll create a really simple table with a single field. And it says query succeeded. And if I look under tables, I've created my admin test table. So creating a table requires administrator privileges. Now if I go back to my resource group and I go into my SQL Server instance, this is where that user is actually defined. If I go down to properties, I have in my list of properties server admin login. So it knows I'm bbrooks26. And it also has this other one called Active Directory Admin, and it says not configured. Now what this is about is the server admin allows you to have a standard SQL Server credential login for administration. You can also associate an Active Directory account as an administrator. And on the left here, you'll see I have Active Directory Admin. If I click on that under Settings, it takes me to a page where I can actually set the admin. Now, in order to set the admin, I need a user. So what I'm going to do is I'm going to go back to Home, and I'm going to go to Azure Active Directory, and let's create a user that we'll use as an administrator. So in Azure Active Directory, I can go under Manage Users, and you see it's just me in here. I can click New User at the top. Okay, so I'm going to leave it on Create User, and I'll just give it a new username, and we'll call this AAD user, Azure Active Directory user that I'm creating. You normally give it a proper name and a proper username, but for name I'll just call it AAD for simplicity. I don't actually need to give it a first or last name. And under password, I'll create the password, and I'm going to give it a dummy password that I use all the time. So I hit create. Okay, so it's created my AAD user. Now I can associate that as the administrator of my SQL Server instance. So if I go back home and I go to Resource Groups and Azure 26, and I open up my SQL Server instance, and then in the menu on the left, if I click Active Directory Admin, I can click Set Admin, and I can now choose my AAD user and hit Select, and then hit Save at the top. Now that says it's successful, and so now when I go to Properties, I see it under Active Directory Admin. That's the user. So one thing we need to do is we need to log in to the portal as this user, because the first thing that's going to happen is that the system's going to ask the user to change their password. So if I don't do that password change on behalf of the user, it's going to cause problems when I go to log into SQL Server. So I am going to log into the Azure portal as my new user. Next, I will enter the password. And here it asks me to update the password right away. So I have to give it the password, and I'll give it another password that I can remember. Okay, so we've just set the password for that user. So I'm now going to close this, and let's go back to the portal. So now what I want to do is I want to show you that I can log in as this Active Directory user. So what I'm going to do is I'm going to go to Microsoft SQL Server Management Studio. And I'm going to show you that I can log in as that AD user. So if I go to File, Connect, and in the portal, if I go to Overview, I can copy the server name. And then if I go back to Microsoft SQL Server Management Studio, I can copy that as the server name. And I can choose Azure Active Directory password as the authentication type. And I'm going to just go back and get my username. So if I go back to Properties on my SQL Server, I can copy the Active Directory admin username. And there's my AAD username. And I'll put in the password that I gave it and click Connect. And you see I can connect to the database. So that means that I'm authenticated. I can see my MyDB. And if I go to Tables, now you can see the table that I created with my regular SQL Server Authentication admin user. Now I should be able to create a new table using this user as well. That would show that I have admin permissions. So I'm just going to give it one field here. That's good enough. And table 1 is fine. And it looks like it created it. So if I right-click under Object Explorer and hit Refresh on Tables, I now see my table 1. So what I've done is I've used an Azure Active Directory user as an admin. This is useful because it allows other resources in Azure to interact with the SQL database with those credentials. Now, the last thing I'm going to do is show you how to create an admin user internally in the database so you can actually set up objects in the database that will create an admin user that you can then log into the SQL Server with. So the first step of this is to create what's called a login. Now a login is not a user, but it's simply a set of credentials that can be associated to a user. So in my database here, I'll stay logged in as this user, and I'll go open up Security under Object Explorer, and I have a folder called Logins. I'll expand that, and you notice I have one login, bbrooks26. That is my SQL Server admin login that I set up with the server instance. Now, why isn't my AAD user here? Well, my AAD user is not here because that is an Azure Active Directory user. So the details of that user and their login is actually stored in Azure and not here in the database. So let me create a new one. I'm going to right-click on Logins and go New Login. And I'm going to create a new login. I'm just going to fill this in. I'm going to create a login called Sqlmd. Create login Sqlmd with password. And I'm just going to give it, this is a common password that I often use that meets all the password criteria. And if I hit execute, commands completed successfully. So in Object Explorer, if I right-click on Login and I go refresh, I now have a new login credential called Sqlcmd, and it has that password. So the username is Sqlcmd, password is the password I gave it. Now if I open up databases, what I want to do is I want to make that user a user in MyDB. So if I expand MyDB, there is a section under it called Security, and if I expand that, there's a section called Users. Now, what I'm going to do is I'm going to run a query that creates new users. If I open up users, you see there aren't very many users in here, just the standard default ones. So I'm going to click New Query up in the menu, and I'm going to copy a query that creates the user. Create user Sqlcmd for login Sqlcmd. So I not only create the user, I associate it to the login we just create. I hit execute. Now if I go to my MyDB database and I right click on users and I hit refresh, there's now a new user called Sqlcmd. What this means is I should be able to log in as that user. So let's go back to the portal, and under my resource group, I'm going to go to my database, MyDB, and on the left I'll click Query Editor. And now, instead of logging in as bbrooks26, I'm going to log in as Sqlcmd, the user that I just created. So I click OK, and now I'm logged in. So it allows me to log in as that user. So let's try to create a table using this user. So I go Create Table, SQL Table, and I will give it a simple field and hit Run. Now look at the message we get in the response. Failed to execute query, error, create table, permission denied in database MyDB. So we have a user that is authenticated, but they do not have the permission or the authorization to create tables. So how do we give this user permissions to do that? Well, let's go back to the SQL Server Management Studio. And what we need to do is we need to give that user the proper role. So I still have MyDB open, and I have security users open, and there's Sqlcmd. Now let me open up the roles folder under security, and there's a folder called database roles. If I open that up, there are a bunch of roles, and one of the roles is DB_owner. Now if you give somebody the owner privilege, that pretty well gives them rights to do anything with the database. So let's assign that role to our user. And I'm going to click New Query at the top, and I'm going to copy a query here. And the way you do it is you actually add the member, which is the user, to the role. So I go alter role DB_owner, add member Sqlcmd, execute, and it says that's successful. So now if I go back to Azure, let's try to run this query again. Now it says succeeded. And if I refresh and I look at the tables, I see the SQL table that I just created, and I also see the other tables that we created. So just to recap, what I've shown you here is 3 separate ways that you can associate an administrator who can log in to your database and administer the database. One of them is that when you create a new SQL Server instance in Microsoft Azure, it automatically creates an admin user for you that has SQL credentials. So you need to give it a username and a password right off the bat. The next way is to have an Azure Active Directory user and associate them as an administrator. And there are settings in SQL Server to do that, as I've shown you. And the third way is to go to the database itself and actually create a user in the database associated to a login in the database. In this video, I'm going to demonstrate how to install and use Azure Data Studio, which is a cross-platform database tool from Microsoft. You can use Azure Data Studio to interact with local databases as well as cloud databases. In this demo, I'm going to show you how to connect to an Azure instance of a SQL Server database. I'll also briefly mention some of Azure Data Studio's other features. So to start off, you'll have to install Azure Data Studio. It's a local install, and you can go to this public Microsoft Docs page, called What is Azure Data Studio? And there's a link on it called Download and Install Azure Data Studio. Now, if you go there, you can install an MSI for Windows. And you can basically just choose the default settings during the installation, and you'll have the same thing that I have installed. So let me go to my Azure Data Studio, which I've already installed. Now, the first thing I'm going to point out is under Connections on the left-hand side, I have two sections, Servers and Azure. So I'm going to show you two ways in which you can connect and use a database. Now, I have a database already set up in Azure. So the first thing I'm going to do is go under Connections, and I'm going to click New Connection. And this lets me create a SQL login connection. So under Authentication type, I have SQL login. Now I need a server name. So let me just go to Azure and grab that SQL server name. So if I go to Azure, I have my SQL database opened up. And in the overview, there's a server name. So I'll just copy that and then go back to Azure Data Studio and paste that for server. Now Authentication type, SQL login, username. Now there's an admin user that you set up when you first create the SQL database, and I'm using that. So my username is bbrooks26, and I'll enter my password. And I'll click Remember Password so it remembers me, and click Connect. Now it's connected. So on the left-hand side, you see my connection here, and I can open up a folder called Databases, and I can see a database that I've set up called MyDB. So I'm going to right-click on MyDB and click New Query. And what I'm going to do is I'm going to show you some queries live here that I've set up. I'm going to copy them here. So I'm going to create a table. I'm going to insert some data into that table. I'm going to call a select to see the data, and then I'm going to drop the table. So the table on line 1 is called Demo User Table. It has a first name, which is a string, last name, which is a string, and age, which is an integer. And the nice thing on this query is I can just highlight what part of the query I want to run. So I'm not going to run the rest of this yet. I'm just going to highlight line 1 to create the table. So I'll click Run. And it says in my messages that it completed successfully. If I go to the left and I right-click on my database and I hit Refresh, and then I open it and open the tables, I see my table, Demo User Table. Now, if I highlight lines 3 through 9, this is an insert into that table. It inserts the first name, last name, and age. And I have 4 records that I'm entering. Joe Smith, who's 56, Barbara Young, who's 12, Edna White, who's 88, and Larry Bly, who's 38. So if I run that, it says in the messages that it's complete and 4 rows were affected. So now I'm going to query that data by highlighting line 11, select star from Demo User Table. So that will select all my data. And you see in the results all of my data, all 4 records, first name, last name, and age. So that was successful. So on line 13, I'm going to run drop table demo user table, hit run. And now if I go to the left and I right click on tables and hit refresh, now the table is gone. So what I've shown you is a complete set of queries that I've run to create a table, populate it, show the data, and drop it. Now what I'm going to do is I'm going to use the other connection that's under Azure. Now the server's connections, they can be connections to any database. It could be a local database that you have on your machine. It could be a cloud database. It could be other types of databases. The Azure connection allows you to connect to databases in Azure based on your subscription. It'll show all databases under that subscription. So first thing I'm going to do is right click and hit delete connection under servers. And I'm going to close this query. Then I'm going to go to Azure on the left, and I'm going to click plus, and I'm going to click add an account under linked accounts. And what it'll do is it'll ask me to log in. I have a lot of different accounts that I use. I'm going to click the one that I used to create the database, and it says your account was added successfully. So now if I go back to Azure Data Studio, I see that under linked accounts, I have my account. Now this account will have owner privileges on the database because it's the account that created the database. Click Close. Now on the left-hand side under Azure, I can expand it and I can see all my databases under my subscription that's free trial. So I can open up SQL Database and I see MyDB. This is the same database. If I open it up, I can see the tables. I can see there's no table because I've deleted that table. Now let me right-click on tables. I'll right-click on MyDB and hit New Query. Now let's do the exact same thing again using this connection. So first thing I'm going to do is on line 1, my create table line, I'm going to run that. And it says completed successfully. So on the left, if I right-click on tables and hit refresh, I see my table. I'll run the inserts, 4 rows affected. I'll run my select on line 11, and I see those 4 rows in the table, so they're in the database. And now on line 13, I'll drop the table. So if I go to the left and I right-click on tables and hit refresh, now my table is gone. So you see there's 2 ways that you can manage databases, either as single server connections or as a connection to an Azure subscription that gives you a consolidated connection to all of your databases under that subscription. Now, a few other things I want to mention is some of the more advanced things that Azure Data Studio can do. So on the very left, there's a menu in black, and I want to take you to Notebooks and just mention that what you can do here is you can create Jupyter Notebooks. Now, Jupyter Notebooks are used by data scientists to run different processes. And back on the left again, you can also go to something called source control, and you can actually connect to Git source control repos. So you can do some source control in here. And the final thing I wanted to show you is the last thing on the main menu here, extensions. So the functionality of Azure Data Studio can actually be extended by these extensions that you can easily install. And you can see I have PostgreSQL, so that allows me to write PostgreSQL queries. If we just look at a few, there's also Azure CLI, so you can do command line calls to Azure. And there's different ones. There's many different ones. There's some machine learning, some PowerShell. You can do PowerShell. So there's a lot of extension that goes with this Azure Data Studio, so it's very powerful. So in summary, I've shown you 2 ways in which you can connect Azure Data Studio to an Azure SQL Server Database. Create a table, populate that table, query the table, and drop the table. I've also shown you that Azure Data Studio handles more than just database access, allowing Jupyter Notebooks as well as interaction with Git repositories. Its functionality can be extended via an extension library for other functionality. In this video, I'm going to demonstrate how to use Microsoft SQL Server Management Studio to access a SQL Server database in Azure. Now, SQL Server Management Studio, or SSMS for short, has been around longer than Azure has. It was the original tool for accessing on-site SQL Server databases, and it remains a useful tool for doing that. Since the technology for cloud-based SQL Server instances is very similar to an on-site database, SSMS can be used for Azure Cloud instances as well. So the first step is to download and install SQL Server Management Studio. So I have a public Microsoft Docs page is open here that you can find called Download SQL Server Management Studio. And from here, there's a link that says Download SQL Server Management Studio. So if you follow this, you can download the Windows install and then just follow the defaults to set it up. Now I've already got mine set up, so I'm just going to go to it now. And I'm going to show you how you connect to an Azure SQL Server database. So I'm going to go under File and Connect Object Explorer. Mine's already open. And it says Connect to Server, SQL Server. Now I have some things filled in here, but they're not correct. So what I need to do, the first thing I need to do is get the server name. So I can get that from Azure. I've already got a database set up. So if I flip to Azure here, I have a SQL database set up called MyDB, and it has a server name, and I'll just copy that name, and then go back to SSMS and paste it in as a server name. The next step is to choose the authentication type. So this is just going to be a SQL Server authentication. And I can use the same username and password that I set up when I created the database originally in Azure. So my login username has to be bbrooks26. And I'll enter my valid password and hit connect. So I'm connected. You can see on the left, if I expand in Object Explorer the databases folder, I can see MyDB, which is my database. Now I'm going to right-click on my DB and choose New Query. And what I'm going to do is I'm going to run some queries to show you this working. So in the query window, I have several queries, and I can just highlight the one that I want to run. So I'll highlight Create Table Demo User Table. So I'm creating that table. It has a first name, which is a string, last name, which is a string, and an age, which is an integer. So if I hit Execute, down in the messages, you see that it's completed successfully. So on the left, if I right-click on Tables under my DB, and I click Refresh, then I open that folder, I see my table, Demo User Table. Next, I'm going to insert some data into that table. So on the right in my query, I'm going to highlight this Insert Into statement. Notice I first in round brackets have a list of the fields I'm going to insert, first name, last name, and age. And then I have the keyword values. And then I have a list of records in round brackets with the values. So I'm going to insert Joe Smith, who's 56, Barbara Young, who's 12, Edna White, who's 88, and Larry Bly, who's 38. So I'll hit Execute on that. And down in messages, it tells me that 4 rows were affected. So now I'll go to the next one, which is Select Star from Demo User Table. That should show me all of my data in my table. So I'll hit Execute. And down in the results, I can see Joe Smith, Barbara Young, Edna White, and Larry Bly. So the final step is to drop that table. So I have a command drop table demo user table. If I execute that, down in my messages it says commands completed successfully. So now if I go to the left and I right click on tables under my DB and I hit refresh, I now see that my table is gone. So another thing I want to do is just wrap this up by showing you that you can create a table from SSMS and then see it in Azure, just to connect the two together. So now that I've dropped the table, I'm going to recreate it real quickly here, hit execute, and I'll right click and do refresh on the tables just to see that it's there. And there it is. Now I'm going to go to Azure, and let's take a look at it in Azure just to verify that that table exists. So in Azure, under my Sql Database, on the left I can choose Query Editor, and I'll just type in my password and hit OK. And now I'm in the Query Editor, and if I open Tables here, I now see my table. I see that it has first name, last name, and age. So that just verifies for you that I'm using SSMS to create the table. What I'm really doing is I'm accessing a table in the cloud, in Azure, and I can actually go to Azure and see the results. So in conclusion, I've shown you how to connect Microsoft's SQL Server Management Studio to an Azure-based SQL Server Database instance. I've shown you how to create a table, populate that table, query the contents, and delete the table. Now, one of the nice things about using SSMS, it's an older technology and it's been really well used. So a lot of the problems have been ironed out, and it's a very reliable tool. In this video, I'm going to demonstrate how to use the Sql Command Utility to access an Azure SQL Server Database. I'm going to create a table, populate that table, and query the table contents, all with the Sql Command Utility. I'm also going to show you how to run a query from a file using the utility, how to use variables in a query file, and how to output query results to a file. So the first step is to install Sql Command. So right here I'm on Microsoft Docs, so this is a public site. It's Sqlcmd Utility. And there are two distinct installs for whether you have 64-bit or 32-bit Windows. Now the install is super simple. You can download it and just run it, and it will install Sql Command. Once it's installed, you can simply run a Windows command line, and then you can use a Sql Command. So let me do that since I've already installed it. So I have a command window here, and what I'm going to do is I'm going to connect to an Azure SQL Server Database. Now let me take you to that database for just a minute, and I want to show you what it looks like. Here's my SQL Database in Azure. on the Azure portal. You'll notice it has a server name under Overview. You'll see that server name again in the Sql Command Utility when I run the command. So let's go back to the Sql Command Utility. Now what I'm going to do is log in, and that looks like this. It's Sqlcmd and then a dash capital S, and then here is the name of the server I just showed you from my Sql database, and then dash D for database and the name of the database, which is MyDB, dash capital U. This is a user of the administrator user. Actually, it can be any user that has permissions to your database. I'm going to use my administrator user, which I had to set up in order to create the database. So that's bbrooks26, and dash capital P is a password, and this is just a dummy password that I always use for test. So if I hit enter, I now get a prompt, and it says 1 and then a greater than sign. So this tells me that I'm logged in and it's waiting for input. So what I can do now is I can run queries. So let's run a create table query. Looks like this. Create table demo user table. I'm going to have a field called first name, and it has a maximum of 20 characters, and a last name field with a maximum of 20 characters, and an age, which is an integer. Now if I hit enter, you're going to notice it didn't really seem like anything happened. I now have a new prompt and it says 2 instead of 1. It will count the lines sequentially. So this is the second line, and it's not going to do anything until you type the keyword go. The reason for this is because you can run queries in bulk and then just say go at the end and it'll run all of them. But I'm just going to run this one by itself. And now notice my prompt says 1. That means that this was successful. It doesn't really tell you anything on success, but it would tell you if there was an error. And so the table should have been created. Now let's go back to Azure for a second. And I'm just going to go to the query editor in Azure. And I'll just log in, just to verify that that table exists. So if I open up tables in the query editor, you can see demo user table is there. And if I open it up, I see my fields, first name, last name, and age. So it definitely created the table in Azure. So if I go back to the command line, what I'm going to do now is I'm going to insert data into that table. And this is a multi-line command. So I have 7 lines here. Insert into demo user table. I have the fields listed, the keyword values, and then I have 4 records with their values in round brackets. Joe Smith, who's 56, Barbara Young, who's 12, Edna White, who's 88, and Larry Bly, who's 38. So if I hit enter, I'm on line 8, and to run this, again, I have to type go. Now it tells me 4 rows affected. So that should have populated the table. And if we go back to Azure and I run a select star on that table, and indeed I can see the contents. So it definitely sent those contents to Azure. Now let's see how we can query it here in the Sql Command Utility. So I'm going to get the select statement. Here we go. And I type go. And we see a nice display here, first name, last name, and age. And there they are. Now I'm done my querying. So what I can do is I can type quit. And it will disconnect, and you can see that I'm back to the command line. I'm just going to type in a CLS to clear the screen. Now my table still exists in Azure because I've created. I populated it. Now let's take a look at how I would run a query from a file in order to query that table. So what I want to show you is a file I have set up. It's on my local drive, and it's Sqlcmd select.sql. And it's really simple. The contents of this is just a query. Select star from, but the interesting thing is I have a variable here. $sign and round brackets and table. I could have put the table name, but I want this to be like a template. And I want to be able to select any table. So I want to send that in as a variable. And that's how a variable looks for the Sql Command Utility. So I'm going to run that file. And if I just go back here, So here's the command. It's Sqlcmd. And again, we have the server, just like we did before. We have the database, just like before, the user and the password. So all the connection details. Now here's where the new stuff starts. -i, and then I have the full path of the SQL file. So I'm telling it which file to run. That's what I means, is to run the contents of this file. After that, I have a -v. That stands for variables. And what follows variables are key value pairs for the variables, and they have to be separated by equal signs. I only have the one. So my variable name is table, as you recall in the actual query in the file. And then I give it the value, which is demo user table. So that's what's going to be replaced by that variable when I run the file. So I'll hit enter. And just like before, it ran the select in the file and it outputs the results. So I'm just going to clear the screen. And what I want to show you now is how to output results to a file instead of to the screen. So I'm going to start with the same SQL command that runs the file. And what I'm going to add is the argument -o. And by the way, these arguments are case sensitive. So some are small and some are capital case. You have to pay attention to that. And I simply give it the output file name with the full path. So I'm going to call it output.txt. I'm going to run that. And it's finished. Now if I go back to my SQL command folder on my local drive, I now have an output.txt. If I open that, you see that I now have my output in the file. So that can be very useful for automated processes where you want to record the result. So in summary, I've shown you how to log into an Azure SQL Server Database using the Sql Command Utility, create and populate a table, and query the table contents. I've also shown you how to run a query from a file using variables and how to output to a file. The Sql Command Utility is very handy for automating SQL commands, since sets of queries can be placed in SQL files and then automatically run via a script. Microsoft Azure offers 3 ways to host your data on the Azure cloud using SQL Server. There are Sql Databases and Sql Managed Instances, and there are also Sql Virtual Machines. In this video, we're going to look at how to set up Sql Virtual Machines in Azure, some details to be aware of, as well as some benefits of running SQL Server in this manner. Let's start off with some of the benefits of running Sql Virtual Machines. First, the licensing cost for Sql Virtual Machines is much simpler than hosting your own infrastructure on premises. Azure offers pay-as-you-go licensing, so you don't have to pay up front like you would with your own servers. And Microsoft takes care of maintaining the infrastructure behind the scenes, so you don't have to. It's a great way to get a SQL Server instance up quickly, easily, and with no upfront infrastructure costs. Azure Cloud offers you the ability to deploy Sql Virtual Machines in many geographical regions around the world. Perhaps you have customers around the globe who could benefit from fast access to your SQL Server database. You can deploy an instance close to them for low latency. And Azure makes it easy to find the right combination of infrastructure resources by offering a variety of machine sizes for different workloads. Choose a virtual machine image that matches the version, edition, and operating system that best suits your needs. There are many useful configurations you can take advantage of for Sql Virtual Machines. First, you can back up your database to Azure storage, either automatically or manually. Azure Backup for SQL VMs is an enterprise-class backup solution that lets you centrally manage multiple database backups and restore from points in time. You can set your own retention rules, and you can back up data potentially for years. If you require high availability, there are SQL Server availability groups. In this configuration, you set up multiple Sql virtual machines, and Azure treats them as a virtual network, automatically managing traffic to them. You can set automated patching to automatically update SQL Server on a regular schedule. And you can control performance by selecting the proper virtual machine infrastructure for your needs. Azure offers several tiers of infrastructure to choose from. When you set up an SQL Virtual Machine in Azure, you have two options for SQL connectivity type, public or private. Choose public if you want your SQL Server accessible outside the virtual machine. Otherwise, choose private. Whichever one you choose, Azure goes through some common setup to prepare your instance. These steps are setting a firewall rule to allow SQL Server traffic over a TCP port. The default port is 1433. SQL Server Authentication is enabled, as this will be how users log into your database. The TCP/IP protocol is enabled for SQL Server, and if you choose public SQL connectivity, a network security group will be set up for the traffic on the SQL Server port. If you chose private SQL connectivity, this step is skipped since you don't want traffic coming in. Once you have your SQL virtual machines set up and running, you might wonder, how do I migrate existing data, say in an on-premises SQL Server instance, to my SQL virtual machine? Microsoft offers several options for doing this. First, you could detach your data and log files on-prem, copy them to Azure Blob Storage, then attach them to your SQL virtual machine using the URL to the blobs. Alternatively, if your on-prem instance is an always-on availability group deployment, you can use the Add Azure Replica wizard to replicate your database to Azure, then fail over to that Azure instance. You can also simply create a backup of your database on-prem, compress it, then copy it to the Azure VM and uncompress it. You also have the option of creating a new Azure VM by converting your on-prem machine to a Hyper-V virtual hard drive, and then uploading it to Azure Blob Storage. Azure has an option to create a new virtual machine out of a general Hyper-V virtual hard drive. And finally, you can take advantage of SQL Server transaction replication. Your SQL virtual machine can be the subscriber to the replication, and once you've replicated from on-premises, simply disable replication, and users can use your Azure SQL virtual machine. Now, I started off by mentioning the many ways you can host SQL Server on the cloud with Azure. It turns out that Azure offers a consolidated view for managing all of those various Azure SQL resources in one convenient location. If you go to the Azure SQL resource in Azure Portal, you will see a list of all the available SQL resources in your subscriptions in tabular form. You'll be able to see Elastic Pools, Managed SQL Instances, Azure SQL Databases, SQL Virtual Machines, and logical SQL servers that correspond to your SQL databases. In this view, you can add new resources, delete resources, or configure the resources that you have. There are a few details to keep in mind when deploying a SQL virtual machine. You create a SQL virtual machine by selecting a virtual machine image that matches your required resources. Note that these images correspond to the operating system, SQL Server version, and SQL Server edition combinations. And as new images come online, some will be deprecated and eventually removed. You'll have to be aware if the version you're relying on is being removed. When old versions are removed from the portal, they still remain active for 3 months, and you can still deploy them during that time using PowerShell, even though they aren't listed in the portal. Another thing you should be aware of is a Customer Experience Improvement Program. By default, your SQL virtual machine will be configured to send periodic reports to Microsoft as a way to improve SQL Server. This runs in the background and doesn't require any action from you. But if you don't want these reports sent, then you need to connect to your SQL virtual machine using Remote Desktop and run a utility called the Sql Server Error and Usage Reporting Utility. This will allow you to disable these reports. In this video, we're going to look at one of Azure's solutions for SQL Server in Azure Cloud, the Azure SQL Managed Instance. This is the optimal solution for organizations who want to do what's called a lift and shift with their current on-premises network SQL Server instances. SQL Managed Instances offer almost full compatibility with the latest Enterprise Edition SQL Server Database engine, wrapped in a platform as a service offering, so Microsoft manages it for you. The service adds intelligence to your solution with features such as backups and auditing. Being a platform as a service, SQL Managed Instances are highly scalable. They can be easily integrated into a virtual network or VNet, which is a network of virtual machines in the Azure cloud, which can replace your on-premises physical network, making moving everything to the cloud much easier. So let's look at some key features and capabilities. Azure SQL Managed Instances offer business continuity. If you're already running SQL Server on-prem, you can move to an SQL Managed Instance and get virtually the same features, with a few small exceptions. Compare this to another Azure offering, Sql Server Database. Sql Server Database is a more general offering that has a more limited set of features. For example, Sql Server Database cannot perform cross-database queries, whereas SQL Managed Instances can. SQL Managed Instances have high 99.99% availability with both automated and customer configurable backups and point-in-time restores. You get all the platform as a service benefits. You can get up and going with no hardware purchases. Microsoft manages your hardware infrastructure, and they do automatic patching and upgrades. Additionally, it can be integrated with other Azure Platform as a Service offerings. Compare this to Azure Sql Virtual Machines, which is an infrastructure as a service solution. SQL Managed Instances don't give you the fine-grained control over the SQL infrastructure configuration that Sql Virtual Machines do. But that also frees you to not worry about infrastructure concerns. SQL Managed Instances are secured by Azure Active Directory authentication and data encryption, and, like Azure SQL Databases, they meet compliance standards. They also offer comprehensive SQL auditing and threat protection. SQL Managed Instances have two tiers to choose from. Both tiers have high 99.99% availability and allow you to configure resources such as storage and computer capacity. General purpose is for solutions requiring typical performance. It uses Azure Blob Storage, which has built-in high availability. If you're not running business-critical applications, this is the tier to use. The other tier is business critical. It offers solid-state drive storage for very high performance to guarantee low latency. It also offers read-only replication of the database to guarantee data integrity, and has in-memory online transaction processing, which makes business transactions reliable. Azure offers management operations on your SQL Managed Instances via their API. The operations offered are categorized as instance deployment or creating a new SQL Managed Instance. If you think of your virtual network in Azure as analogous to a physical network on premises, this would be analogous to deploying a new SQL Server instance on that network. Then there's Instance Update, which is analogous to configuring a SQL Server on your network. And Instance Deletion, which is analogous to removing a SQL Server from your network. SQL Managed Instances on a virtual network run with their own dedicated virtual cluster, which is a group of isolated virtual machines. When performing management operations, you should be aware that some operations will result in this virtual cluster being changed under the hood, which may take time. In other words, don't assume that these management operations are instant. When it comes to security and compliance, SQL managed instances have all of the built-in security of the SQL Server Database engine, since it's this engine running in the background. Because it's an Azure service, it also benefits from the security features of Azure. Some of the security isolation features that come built in are the Azure Virtual Network itself, which has built-in isolation. There are also tools such as VPN Gateway that allow secure integration of the virtual network to an on-premises network. By default, the underlying SQL endpoint has a private IP address, so only private Azure networks or hybrid networks can access it. And the infrastructure is single tenant, which means it's dedicated to your tenant and is isolated and not accessible to other Azure tenants. SQL managed instances are fully integrated with Azure Active Directory, which gives you the option of using traditional SQL Server Database logins as well as Azure AD logins. A new option is the Azure AD Server Principal, which allows full usage of users and groups in Azure AD for authorization and performing any operations. With Azure Active Directory, you can also take advantage of multi-factor authentication, where users need to perform an additional authentication step beyond simple username and password. With SQL managed instances, you can back up your data to Azure Blob Storage and restore it from the same storage using standard database backup format. Migration options also allow you to migrate large amounts of data from either an on-premises SQL Server database or one that's implemented in Azure as infrastructure as a service, such as an Sql Virtual Machine. In this video, we're going to look at a data warehousing solution from Azure called Synapse Analytics, which is a solution for analyzing data from potentially many different sources in one common solution. Apache Spark, a powerful analytics tool, is well integrated with Azure Synapse Analytics, allowing you to take advantage of the Apache Spark abilities to analyze your data. The Synapse Studio is a user interface that allows you to prepare, manage, query, and run AI on your big data. Synapse Analytics comes with its own query language, Synapse SQL, which is TSQL based. And Synapse pipelines allow you to build flexible data ingestion strategies right in Synapse Studio. A Synapse Analytics instance can be managed either as a dedicated SQL pool or as an on-demand SQL pool, where you pay as you go. We're going to look at the details of the dedicated SQL pool option. The SQL pool refers to the analytics resources set up when you deploy a Synapse Analytics instance. This is measured in what's called data warehousing units, or DWUs for short. DWUs are a standardized measure of resources and performance that are dedicated to your instance. You can increase or decrease the DWUs assigned to your instance as your needs change. The first step to using your Synapse Analytics instance and the SQL pool that's dedicated for it is to import data. Synapse Analytics allows polybase TSQL queries, which basically makes it easy to migrate large amounts of data from a variety of different databases, both relational and non-relational. Synapse Analytics is a big data solution. As such, it follows these steps. First, the data is ingested. As discussed, this can come from a variety of different sources and can represent a variety of different data. The ingested data is stored in a big data store. Azure Data Lakes is an example of a big data store, as is Azure Blob Storage. The data is then prepped and trained. This means preparing the raw data for analysis, and it can be done by any number of services, such as Hadoop or Azure's machine learning algorithms. This is when Synapse Analytics comes in. The data required for an analysis job, now prepared, is then ingested into Synapse Analytics using Polybase, which models the data into internal data tables that you, as a designer of the analysis pipeline, define. Those tables can then be queried using Synapse SQL to serve the results to the end user, perhaps via a report or ad hoc analysis tool. Now let's talk best practices when using Azure Synapse for data analysis. First, migration of data. As mentioned, you define tables within Synapse Analytics and use Polybase to ingest from a source. Ingest the data as quickly as you can at the beginning of your analysis. This way, the data is there and doesn't have to be loaded later, slowing down the process. You should consider using distributed tables, which split logical table rows into multiple tables and speed query and load performance by allowing concurrency. You should also consider replication, which replicates your table and minimizes expensive data moves when performing joins and group bys. Tables can be defined as distributed or replicated in Synapse Analytics. Make sure to define meaningful indexes on your tables to optimize read performance. Partitioning can help with filter performance. And you want to take advantage of incremental load for performance. This means that when you ingest data into tables, you only ingest changes to the data, not the entire data set. Talking about ways to improve performance, you should make sure that your statistics on your tables are updated regularly. Synapse Analytics makes your queries more efficient under the hood by learning about your data in the form of statistics. A Synapse Analytics database can have auto statistics turned on, so the service is always updating these statistics as your dataset changes. Alternatively, you can manually run a statistics update when your data has significantly changed. You can use resource classes, which allow you to define how much memory is assigned to queries. Proper management of resource classes will make your queries more performant. You can also adjust your resources in Synapse Analytics when they're not being used, which will save you money. You can either pause your compute resources when they're not used or scale them. This can be done via the portal or with scripts that call the Azure APIs. And finally, you should analyze your architecture to optimize performance. Analytics resources can be expensive, so you definitely don't want to pay for resources you're not using. You should look at how your users access your analytics and try to minimize wasted resources while still serving your users optimally. In this video, we're going to look at what sort of connectivity errors you might encounter with Azure SQL instances, such as Azure SQL Database or Sql Managed Instance. We're going to look at what typically causes these issues and what you might do to resolve them. We'll start by discussing some of the most common root causes of errors when a user attempts to interact with SQL Server on the cloud. First is a connection timeout. This means that the user's client has sent a request to SQL Server, but did not receive a response before the configured timeout. This can be caused by slow network traffic or an issue on the server's end. Sometimes errors are caused by incorrect firewall settings. A firewall is put in place to block unwanted traffic. If it's incorrectly configured, it may block wanted traffic as well. Users entering an incorrect login is often an issue. When a user gets a message saying their authentication attempt failed, this is usually the first thing to check. Errors are often the result of bad design, either failure to apply best practices and guidelines when setting up SQL Server, or if an application is running on top of the database, bad design decisions in the application which result in failures in normal conditions. And finally, there are reconfiguration errors. The underlying database is being reconfigured and causes errors. These are usually what's called transient fault errors, and they are typically temporary. The solution for these is often to simply retry the request in a few seconds. The last in our list, transient fault errors, are ubiquitous with distributed cloud systems. Clients that interact with cloud systems will eventually experience transient or short-lived fault errors, simply because the systems can't run perfectly 100% of the time. Eventually, clients attempt to access the server when it's undergoing reconfiguration, or experiencing some minor network difficulty, and they receive errors. Transient fault errors can result from either planned events, such as an update to a system, or unplanned events, such as temporary network traffic overload. These sorts of errors are typically short-lived. If the client simply retries a request a few seconds later, they often succeed. When it comes to databases like SQL Server, transient fault errors can sometimes last longer because a large transaction is taking place, such as a re-indexing of the database. The scenario for transient issues is usually this. A user is using an Azure service and has gotten an error that may tell them to retry the request later. If you're the one who administers that service and you've received a complaint of a transient connectivity issue, there are a few actions you can take. First, you can check the Microsoft Azure Service dashboard associated with your subscription. This is a dashboard you as the admin can personalize, which tells you about issues and outages in Azure worldwide. In this way, you can inform the user if the temporary outage is due to a known Azure issue. If there are no Azure outages that might be the culprit, it's important to note that Microsoft might be doing periodic reconfiguration of your SQL Server instance. In this case, users should simply retry the requests after a short time, such as 60 seconds. As the admin, you should also consider resource limits in your database. If storage limits are being approached, your database may cause errors that look like transient connectivity issues. The answer would be to alleviate those resource limit issues, possibly by scaling your database. If, as the admin, you cannot determine the cause of the issue, and the issue persists beyond 60 seconds, then you can put in a request to Azure support. You need to design applications on top of Azure resources, such as SQL databases, with transient errors in mind, because, as I've mentioned, they'll happen sooner or later. It's not sufficient for your application to merely give up and report an error to the user. Instead, your application must try to re-establish a connection using retry logic. One common way to do this is with back-off retries. If the first request to the server fails, then delay for about 5 seconds before retrying. Then the delay needs to grow for subsequent retry. Of course, there should be a maximum number of retries until your application eventually gives up and reports an error to the user. Retry logic makes your application more resilient to connectivity issues. In many cases of transient errors, your user will never even know something was wrong because your application would have simply retried and succeeded. Many of the code libraries available for cloud development include retry logic. So now that we've discussed transient errors, ways to respond to them, and ways to design your applications to be resilient to such errors, let's touch on some of the more common error codes that might come back from Azure and what they mean. The first group of error codes covers the server not being found or not being able to connect to the server. Error 26, error locating server specified, means that the server could not be found. A client should check their connection. Other things to check is if the SQL Server name is correct and if your SQL Server instance is configured to allow remote connections. Error 40, could not open a connection to server, is very similar to error 26, and the same things should be checked. Error 10,053, transport level error when receiving results, could mean there are network issues between the client and the SQL Server instance. If a client receives error 40615, cannot connect to the server, you should try to use the Azure portal to configure the firewall. This usually means the firewall has rejected the connection, so make sure the IP address of the client matches the IP addresses allowed by the firewall. Another similar error, error 5, cannot connect to the server, may be a similar issue with the firewall. Make sure the IP addresses are open, but also make sure the firewall has port 1433 open. Some other possible errors are connection timeout expired. If this is seen during SQL Server login, this could mean that the pre-login handshake acknowledgement did not receive a response in the time allocated for timeout. As an administrator, you'd want to track down why the server is not responding in time. Another is the underlying provider failed on open. This basically means that a request was made to the SQL Server and it's not responding. Again, you would want to track down why SQL Server is not responding appropriately. And a simple timeout expired during a request suggests the same thing. All three of these errors imply that the SQL Server instance is either not responding to requests at all or has a high latency. Your client may get the error "cannot open database." This means that the account trying to access the database doesn't have permission. This message usually contains the name of the database being accessed. For example, it may say, "cannot open database master." In fact, if the request is coming from SQL Server Management Studio, it defaults to the master database. So if the account does not have access to the master database, and many clients may not, especially if they're not administrators, this error may come up. Basically, the client must try to connect to a database for which they have the proper permissions. A transient connection error, also called a transient fault, is an error that's temporary and short-lived and can ideally be handled by the logic of your program without the user being seriously affected. Your client applications should contain configured retry logic, which attempts to retry a request if a transient error is received. It's important for your application to determine, usually via context and error codes, which errors are transient and which are not, because retrying a non-transient error is a waste of time. Many transient errors occur during connection to the database. Your application must build a connection string that allows it to connect to the database, and sometimes this connection string can be altered to force a new connection, which alleviates some transient errors, as we'll see. Also, adjusting connection strings is sometimes a way to alleviate transient errors. Your application may receive a transient error in two conditions when talking to a SQL Server instance, either during connection or during a command such as a query. Generally, if the error occurs during connection, the application should wait for a few seconds before trying to connect again. If it's an error during a command, often simply waiting and then retrying the command won't work. Instead, the application should wait a few seconds, then try to establish a new connection, dropping the old connection. Then the command should be retried on the new connection. So let's step through a scenario involving a transient error and what steps the application should take. We'll assume that a transient error has occurred after a series of commands that was part of a transaction has been attempted. Right after the transient error has occurred, the application should open a new connection to SQL Server. On this fresh connection, assuming the first command was a select, the select is rerun. If that's successful and the next statement was an update, then the update is executed. If these two commands represent a transaction, then the logic must make sure all the commands succeed. If a command fails, the logic must roll back the transaction, meaning issuing commands to put the database back to the same state as before the transaction began. Note that in distributed systems, this is not always possible. For instance, if the connection is lost for a long period of time, the commands to roll back may themselves fail. But rollback should be attempted regardless, and a high priority log and error message issued in the case that the transaction was not rolled back. For batch programs, such as those run after hours, retries can be spread out because usually these are long-running, and so spaced out retries are not an issue for interface users. For errors that affect user interface program, you should wait 5 seconds before retrying, and you should back off retry attempts exponentially until 60 seconds is expired. Then give up and show an error. Users will usually give up and assume the interface has failed after a minute. One caveat is that some of today's client libraries already have retry built right in, and so you wouldn't have to implement it yourself. It would be redundant. Many .NET libraries for Azure have built-in retries on fail. Make sure the library code you're using doesn't already implement some retry logic before implementing your own. There are also third-party libraries that you can get that implement common retry logic, so you don't necessarily have to implement it yourself. So to prove my last point, the .NET library's system.data.sqlclient.sql connection class has retry logic built in, and you can control its behavior through 3 properties on that class. Connect retry count controls how many times a retry logic will retry before giving up and bubbling the error up to your application logic. Default is 1, but you can set it anywhere between 0 to 255. Then the connect retry interval property controls the time between retries in seconds. Default is 10 seconds, but you can set it between 1 and 60 seconds. And finally, you can set the connection timeout, which is how much time goes by before the retry times out and the error bubbles up to the application. This defaults to 15 seconds, but can be between 0 and a very large number of seconds. Note that to avoid the retry timing out before all attempts are made, set the connection timeout to be greater than or equal to the connection retry count times the connection retry interval. And finally, note that this retry is opaque to your client application. If there's an underlying error, but the retry manages to succeed, your application will receive a success response. The application will only get an error response if the retry fails, either because it tried the maximum number of times or the timeout was reached. Now there are some subtleties in how the Sql Connection library performs its retries, which application developers need to be aware of to make informed decisions on how to write their applications. The library performs retries in 2 situations: when an sqlconnection.open call is made to connect to the database, and when an sqlconnection.execute call is made to execute a query. Now, if a transient error occurs on connection open, it will be retried. However, if a transient error occurs on an execution of a query, such as in the execute command, it does not try to reconnect, nor will it retry the query. If the query itself returns an error, it will simply fail. However, it will do a quick test of the connection before executing the query, and if this shows a problem, it will attempt to retry the connection. If the retry is successful, then it will perform the query. When diagnosing a connection error, here are some steps you can take. Sometimes connectivity errors are caused by communication ports that aren't open, either through incorrect port configuration or being blocked by a firewall. So check that appropriate communication ports are open by testing communication to them. Always check server logs to see if there are any clues to connectivity errors. If clients are having trouble connecting to a database, try connecting to the database with utility applications to see if you can replicate the issue. SQL Server also has its own logs, so make sure you check for clues in the Sql Database logs. And before errors become a problem, make sure your services appropriately log their errors. This will be invaluable during diagnosis. Now here are some ways that you can fix connection issues. Whether you attempt these will depend on the symptoms of the error, so use your best judgment. But you can often correct the problem with these tips before having to dig deeper, or at least temporarily alleviate the problem until you find the root cause. If the problem is connection timeouts, you can consider increasing the connection timeout value. 30 seconds is a standard timeout value for network connections. As mentioned, you can use a client utility to try to test the connection. This may give you a better idea of what the problem is. Check configuration to ensure the correct port numbers are being used. And as a final note, SQL Server Management Studio is a great utility for testing connectivity, since it's easy to use and can be used to cover different connection scenarios. So in this course, we've examined basic management tasks for relational data. We did this by exploring methods for deploying relational data, Azure SQL Database security features, AD authentication with Azure, Azure Data Studio and Sql Server Management Studio, using the Sql Command Utility, Azure Managed Instance and Synapse Analytics, and Azure SQL Connectivity Errors and Issues. In our next course, we'll move on to explore provisioning and configuring relational data services.